In this video, we're going to be solving this problem and discussing how to solve it on graphing functions and transformation of functions under Algebra 1. The problem statement says, how many real solutions are there to the equation square root of x plus 5 equals absolute value of 2x? Okay, so basically what we have here is two functions. Just to make it easier on ourselves, we're going to call the first one f of x equals square root of x plus 5. That first one there. Our second one, which we're going to call g of x, is going to be the absolute value of 2x. Okay, so we have two functions defined right there, and now we can use some already existing information to help solve the problem. So it's going to be kind of hard to figure out and make a table for all the values of x and satisfy square root of x plus 5 and all of this and equals to absolute value of 2x. That's going to be very hard and very cumbersome to do. So what we're trying to do here is we need to find the graphs of these two functions, because when we find the graphs, to find the solutions, we need to find the intersections between the graphs of these two functions. So let's start off by finding the graphs of the two functions, starting with f of x. So square root of x plus 5. This could be a little bit hard because we have to make a table, then we have to deal with all the negative values and the positive values, and then we have to account for the plus 5. So let's not do that. Instead, let's use the graph of square root of x. So to find the graph of square root of x, that's very simple. It's literally just find some easy values. I mean, obviously, x equals 1, that's going to give you 1. X equals 4, that's going to give you 2. X equals 9, that's going to give you 3. All we have to do now is plot some of these points to get a general idea of the shape on this coordinate plane here. Okay, we're going to get these points in here. And then 9, 3 is going to be somewhere off here. So we can see it's kind of a sloping upward line here, starting from the origin. Not such a great line there, but you get the general idea. It's starting from the origin and going out towards this direction. Okay, so now we need to use this information to find the graph of the function square root of x plus 5. So whenever we have a plus 5 like this under the square root or other parentheses within the function like this is a special type of function transformation. And this transformation means, this is going to be very counterintuitive, but we're translating the graph 5 units to the left along the x-axis. So if you see a plus 5, treat it like a minus 5. You're moving 5 minutes into the negative range of the x-axis. Similarly, if you see a minus 5 or a minus anything else, you're going to move that number of units to the right on the x-axis. So this is a transformation of function. This is a horizontal transformation. So what we need to do is move 5 units to the left. Use a different color here for the graph of square root of x plus 5. There go 0, 1, 2, 3, 4, 5. We're starting there. It's going to be the same exact shape. We don't have to be exact here. Just trace a general shape. It's going to go out like that. So it's going to be basically the same graph, but going out from a different origin. So that's what generally it's going to look like. All right, so we've successfully graphed square root of x plus 5. Now we move on to absolute value of 2x. Okay, so to do this, since finding the absolute value of 2x might be a little bit difficult, why bother with that when we already know how to find the graph of absolute value of x? Very simple. I mean, if you input x -1, you're going to get 1. You put 0, just going to get 0. 1, going to get 1 out of it. And then 2, you're going to get 2 out of it. So all you have to do is go in and plot these on the graph here. 1, 1 is already plotted there for us. And we can see a parabola shape emerging. You've got the vertex here, 0, 0. You've got -1, 1 and 1, 1 on either side. We can then fill in -2, 2 on the other side using the shape of the parabola. So then we just draw these through. It's not actually a parabola, but it's easy to think of it as a parabola when you're graphing it just to help fill it in. It's actually more like a V shape, as you can see. So that's the graph of absolute value of 2x. Next, we can graph the absolute value of 2x. So this black one was the absolute value of x. Okay, so when we graph the absolute value of 2x, we're going to need to use a totally separate function translation technique, or transformation. And this is the horizontal compression with factor 2. Because as you can see here, we're multiplying x by 2. And this is a horizontal compression, meaning you're shrinking down that function horizontally along the x-axis by a factor of 2. Essentially, you're cutting it in half. So, we've got our black graph here with the V shape. That's the original one. Then we need to cut this thing in half. So, we basically need to close it up. It's still going to be originating from 0, 0, because half of 0 is 0. But it's going to be closed up. So, instead of going out to the side here, it's going to come through 1, 2. Because the original point was 2, 2. Half of 2 is 1 along the x-axis. That's why our x value is now going to be 1, but for the same y value, as you can see here. It just moves 1 to the left, or in half. So then we just draw this through. As you can see, our V shape is slightly closed in. It's originating from the same point, but it's narrower, as you can see. So in red, we have the graph of absolute value of 2x, and in blue, we have the graph of x square root of x plus 5. So we've successfully found the two graphs of the functions, and our final step now is to find the intersections between the red and the blue graphs. Zooming in here, we can see two distinct solutions, here and here. Notice they didn't ask for the coordinates of the solutions, so all we have to do is find the number of solutions, and that's 2, as you can see here in the green. So to concluding our problem here, there are two solutions to this equation. Square root of x plus 5 equals absolute value of 2x. So basically, all we had to do there is first graph the functions using the transformation of functions technique to make it easier to do by solving simpler problems first. Then, we found the intersections of the two graphs. That was a video on solving a problem using transformation of functions in Algebra 1 on graphing functions.